Hello, Geometry Otters. We're going to be talking about proofs today, especially the two-column proof. We're picking up where we left off with chapter 2.5. So we're going to start with proof. So proof is a convincing argument using deductive reasoning. Okay, so deductive reasoning is using established facts and building off of those to make a point. Okay, so in order to do proofs, we have to have facts that build off each other so that we can eventually get to an end. A two-column proof is a proof with statements on the left and reasons on the right. Okay, obviously the reasons are related to the statement that is on the left. Okay, so over here we have a kind of just an example of what a table would look like, two-column proof. So the first thing we always want to list are the givens. Now the givens could be in a diagram, it could say it is given, okay, but we always want to start with the givens. That's always our first step. Okay, what is the basic information it's given us? Okay, now this is what we are trying to prove. What we are trying to prove. Okay, this is always the last thing that you do. Okay, this is your final step. All right, so that's basically the layout of what a two-column proof will look like. The best way to do it is to see it through an example. So here we see, what is the value of x? Justify each step. Here we have some lines, some angles, and we are asked to find the value of x. Okay, there's some assumptions we have to start with. Okay, as we can see here, we have two angles that together make a straight line. Okay, so these two angles combined make a straight line. That's called a linear pair. Okay, so it's a pair, two angles that make a line, linear pair. Okay, so that's our first step. That's what we see. We don't know the value of x. We see that we have some values for the angles. Okay, so this is our first step. Now let's call this, let's make this a green angle. Okay, or close enough to green. Okay, and we're going to make this a blue angle. Okay, just to show that it's a little bit different. Okay, this will be easier for us when we are labeling. Okay, so our first step, what do we know? Well, we know we have an angle AOC. Okay, let's use red, and our blue angle MOC, and we're going to go over naming conventions, how we name these angles in chapter 1. So that will be next chapter. Pardon me, not equals. We don't know that yet. Are supplementary. Now I just threw out a word. Okay. Supplementary means what? Supplementary means that they equal 180 degrees together. Okay. That's supplementary. If you remember back to former math classes where two angles add up to supplementary. Remember, two angles adding up to 90 equals a complementary angle. Okay, so AOC and MOC are supplementary. Okay, and the reason is they form a linear pair. Okay, a straight line is equal to 180 degrees. So if two angles form a straight line, then they are known as a linear pair or supplementary. Okay, now let's build off of this. Angles AOC plus MOC equals 180. Okay, that's the logical next step. If they add the two angles together, it's going to equal 180. Why is that? Well, that's the definition of supplementary angles. Okay, you're probably like, why do we need to list that? I mean, isn't that kind of assumed? If they're a linear pair, don't they add up to 180? And you're going to see why we do that. Okay, we justify each step. Each statement helps us lead to the next one. Okay, so we add a little bit of information, add a little bit of specifics each time that we do this, okay? So that's definition of supplementary angles. Sorry, I forgot the angles part. Okay, now, next step. Okay, well, how does this help us? We don't know AOC, we don't know the value of MOC, but we do know the expression, the variable expression that they have. So we know that 2x plus 30 is the same thing as AOC. We know that MOC is equal to x, so those two added together should be 180. What do we do there? How do we go from this to this? What we did is we used the substitution property of equality, okay? That's what we did. We substituted the values. We knew that these values here could be substituted in for their angle, okay? Again, we want specifics. So we want to make it more and more specific. We started out general and then we made it more specific, okay? Next step. What would you do? Well, if you're just doing this algebraically, which that's where we are now, is we're just going to solve this algebraically, we have 2x and x that we would add together, give 3x. Now, my question for you, is that the addition property of equality? The answer is no. The reason being is we didn't add something to both sides. That's the only time you can use the addition property of equality. In this case, this is just the distributive property. Okay, or combining like terms. Okay, so that's what's going on there. Now, let's take it to the next step. Our next step, we would subtract 30 from both sides to get 3x equals 150. And if we subtract it from both sides, what is that? That is the subtraction property of equality. Oops, prop of equality. Okay. Final step, divide both sides by 3, x equals 50. Okay. What is this property? Obviously, it is the division property of equality. Okay. And as you can see, our goal was to find x. What is the value of x? We're asked to prove that. That's our final step. Okay. We didn't have any givens in this case. We kind of had to do some front legwork to kind of establish what this problem was about, but now we are done.